Ananya, am I audible?
Yes.
Yeah. Just 2 minutes, we'll get started. Okay. You can have your notes ready.
Okay.
Ananya, are you able to see my screen?
Yes, sir.
Is it visible? No?
Yeah, I'm able to see the presentation.
Is it appearing small or big?
It's not zoomed in, the presentation.
It's appearing small, right?
Now I can see.
Now it's bigger.
Yes.
1 minute, wait. No, I hope it is big.
Yeah, now it's
Right? Is it big?
yes, sir.
Okay. So shall we get started? Few of you, right? So your name? You're Ashwin. Okay. அப்படியே அதே நிமிஷம். Right. Okay. So you got your books, right? You would have got the materials. Can you open the module 1 part? Can you tell me what are the chapters you have? Yeah. So there you saw that limit. That limit is what I was talking about. Limits and derivatives. I was explaining, no? That part. Okay. So basically, if you see, right, compared to your 10th grade, what did you learn in your 10th grade? Like what were the chapters that were there? 1 minute. Yeah. So in your 10th grade, what were the concepts on which you were concentrating? You understood what were real numbers, and you understood what were polynomials, right? Then you had quadratic equations, then you had pair of linear equations, all those things, right? Basically, what you did there is you learned the basics of those tools to handle in your other grades. For example, you would have learned about pair of linear equations and the applications of them in different kinds of problems, right? So all those things will be applicable in your 11th and 12th. Maybe you'll not be applying only to math. You will be applying it to your physics, chemistry, as well as wherever you have linear equations in multiple variables, right? You're going to use it. Similarly, quadratic equations, you're not going to stop it with that part. You will be applying that formula to solve some problems in different subjects, right? So when it comes to your 11th grade, right, the first thing that we need to start with is the concept of set, right? Because this builds basic to the most important branch of mathematics called as calculus. Okay. So before you understand calculus, if I have to just come in the reverse, right? If you look at the book that is being given to you, what were the names? Set, relations, and functions. If you see the front page itself, you will be able to see. On the cover itself, there are the names, right? Set, then you have relations and functions. Then you have trigonometric functions. Then you have complex numbers, right? Then you have the linear inequalities part. Then you have the permutations, combinations. So if you keep them aside, set is the one that gives you the basic introduction to the concept of relations and functions. So among relations and functions, right, function is the most important part that you need to understand to make your math simple. I'll tell you, I'm just telling you the beginning itself. Functions is considered to be one of the toughest parts, but once you crack it, right, once you crack it, math becomes very easy because calculus is going to be a piece of cake. You will understand why you're doing it. Most of them, what they do is they memorize the formula. They keep studying in that way. It is not going to work. Okay, you need to understand the theory behind mathematics, right? For which I'm repeating, functions is very, very important. But for functions to be understood, you need relations to be understood. But for relations to be clear, you need to be clear with this chapter called as set. Okay, so this is the building block. This is going to be the building block of your calculus. So having said this, shall we get started? Right. Ananya, am I clear?
Yes.
Okay. My voice is audible, right?
Yeah.
No.
No, it's audible.
Audible, right? Okay. So first of all, let's understand what is set. Okay, I'm not even showing you this part. Can you tell me what is your understanding of set? What is set basically? Collection of whom? Collections of numbers and variables. Okay. Why do you think we are studying this in the first place? Apart from what I told you, it is important for the concept of relations and functions. What is your understanding? Why do we even need to study about this? What am I going to achieve out of this? You can say to understand patterns. Okay. Group, one particular group will like this thing, the other group will like this thing. So you can segregate them. Okay. Okay. So basically, you do all these things to have an analysis. When you do a research on something, there is a possibility where in that research, you might come across things which are similar. So things which are similar, what will you do? You will take them and put it under one category. And you give a name to it, right? So when you put it in that category, mathematically, they have set certain rules. It's not that we need to follow the rules. Suppose you're taking that value, let's say you are working on Microsoft Word. You will put it with the help of a comma. For example, let's say there is a common liking between 10 people. You will say person 1, comma person 2, comma person 3. Suppose the same thing you're working in Excel. You have worked on Word and Excel. So when you work in Excel, what do? You put it in a column or you put it in a row. You don't use a comma. So those are all different ways of representing. But what you're doing the same thing. You're not doing something special, right? The same data, you're just trying to put it in different formats of whatever research you have done. You basically collected a data and you're trying to consolidate and put it in some format so that some other person who's taking the work from where you stop will be able to understand. That is the objective. Am I right? So having said this, basically, let's see the concept of this thing. So the concept of set serves as the fundamental part of the present day mathematics. Accepted. That's what we were discussing. Makes sense? So is this applicable only to a particular branch or most of the branches? This can be used in most of the branches. For example, you can use the concept of set in statistics also. You can use it in probability also. Right. So in almost every branch, apart from calculus, which I told you, right? Apart from calculus, you can use it in other branches also. You can use it in trigonometry also. Like what you do is you learn a concept called as domain and range. For all those things, you need to know what is the pattern followed by those variables. Okay, I'll come to that point. So the basic why this is kept as the first chapter is because this gives the lead to the next chapter, which is relations and functions. That's what they told. So sets are used to define the concepts of relations and functions. How they are used, you will be able to understand at the end of this chapter, right? So similarly, if you talk about the study of geometry, that is a pattern, right? You talk about the study of sequences. When I talk about sequences, this you have learned last year in the name of chapter called as arithmetic progressions. So that's the sequence. Similarly, probability, etc. All the concepts require the knowledge of this branch called as set. Okay. So what we are going to do is, in everyday life, we often speak about what the collection of objects of a particular kind. This is more important. So you're going to collect the data or objects of a particular type, and you're going to consolidate them and place it under, let's say you're going to place it in a particular pattern form. Right. For example, you talk about cards. When you talk about cards, or you talk about a crowd of people, or you talk about a cricket team, etc., all these are going to be similar kind of objects. Like let's say the number of players that are there in the cricket team, you can put it under the set. You can name that set as Team India, Team Australia, whatever it is, but you put them in a format. It can be either an Excel format or Word format, or in a mathematical representation of how we are going to see, right? And when it comes to mathematics, this also you have learned last year. So when you talk about real numbers, so you learned about real numbers, right? Basically, what are real numbers? So you can classify them as rational and irrational numbers. But what falls under the rational and irrational numbers? Basically, you can start with natural numbers, right? From natural number, you can generate whole number by adding a zero to it. From whole number, what you can do is you can take out the set called as Z, which is integer. The name of the integer set is Z, I'll tell you. Then from here, what can you define? From here, you can define the rational numbers, right? And similarly, you can define the irrational numbers. And what you can do, put everything in one bubble, and you call that whole bubble as real numbers. So if something doesn't fall under this bubble, you call them as imaginary numbers. So that is what is complex numbers. Okay, just give me a minute. I need to get my charger. Okay. Right. So what were we discussing? Yeah. So real numbers, if they don't fall under the concept of real numbers, we call them as imaginary numbers. So combination of real and imaginary numbers put together, we call it as complex numbers. Okay. Now, see, like let's say there is a probability question where they are saying the odd natural numbers. Then what is the set how is the set going to look like? Odd natural numbers less than 10. It is going to be 1, 3, 5, 7, 9. Similarly, the reverse of India, can I call it as a set? Yes, you can. The vowels that are used in English alphabet, you can call it as set. Then the various kinds of triangles like scalene, isosceles, right-angled isosceles, everything is a collection of set. Similarly, prime factors of 210. So you know how to find this, right? So you do the prime factorization and then write the prime numbers. Then the solution of the equation x square minus 5x plus 6 is equal to 0. How do you do this? This basically, so how do you factorization, right? X minus 2 multiplied with x minus 3 will be 0. X is equal to 2 or 3. You will not write it as, yeah, these two are the possible numbers. So what happens here is each of them are well-defined collection of objects. So basically set is defined as the well-defined collection of objects. So these are all the basics. I'm sure you would have already known, right? No. So listen, the sets that are used particularly in mathematics are, what is this? Natural number. Z stands for the set of integers, Q stands for the set of rational numbers, R stands for the set of real numbers. This is what we are going to use. Z plus stands for the set of positive integers, and Q plus stands for the set of positive rational numbers, and R plus stands for the set of positive real numbers. Right. So what are these things? This N, Z, Q, R, what are these? They are the name of the set. They are called as the name of the set. Name of the set is always represented in uppercase, whereas the objects inside that set are always represented in lowercase. What are those objects called as? You technically call them as elements. But generally, we take it in the lower case. That is how it is noted. You write it. For trigonometry, you will write small t, small r, small I. But the name of the set will be capital. Generally, we don't write it like that. See, if you put it in caps, you'll put a inverted comma like this. Generally, this will put it like this. But generally, you use the lowercase. You use lowercase. See. Okay. So the symbols for the special sets given above are referred throughout this text, meaning those symbols we are going to use it in all other chapters also. Okay. You have seen the symbol, right? What does it belongs to? It's basically a Greek letter. It's called epsilon. So this one we say something belongs to. Okay. So before this, you will have something called as an element. After that, you will have the name of the set. Okay. Yeah. See, listen, the following points are to be noted. These are the important points that we need to note. Objects, elements, and members of the set are synonymous terms. So you can either call them as elements, or you can call them as objects, or you can call them as members. All the three mean the same. Similarly, sets are usually denoted by, the name of the set is always denoted by capital, and the elements of the set are represented by small. So this is something I've taken from your NCERT. Okay. So maybe this point alone, you can write it down. Though you know it, I would suggest you to write it for practice purpose, just to focus here. This chapter is more of theory. Okay. Am I clear till this point? Yeah. Shall I proceed? Ananya, shall I proceed? Ananya, are you there?
Yes, sir. You can.
Shall I proceed? Are you writing?
I'm done writing, sir.
You're writing, huh?
No, I'm done.
You're done? Okay. So, yeah. So, we know that, see, now we are clear with one thing. You are going to have well-defined collection of objects, and our job is to represent them in a particular format, right? So, when I say format, there is a particular rule that we need to follow to represent them so that others are able to understand. You can ask me, am I not supposed to do it in the other way? You can do it. But with respect to set, yes, there are certain things that we need to keep in our mind. What are they? What are things we need to keep in our mind? See, for example, if I take A as the element which is in the lower case of the set capital A, which is the name of the set itself, then how do you say that? We use this language, A belongs to A, but every time writing this belongs is tougher thing. So instead of belongs to, what we use is we use the symbol epsilon, right, which is replacing the word of words belongs to, right? So how do you write it? You write it as A belongs to A. So the format is very simple. When you write something like this A represents what? The one which is before the epsilon is element, and the one which is after epsilon is name of set. Right? This point I hope it is clear. Right? Now, so is there a way where I can write something does not belong to something? Can you? So B is not an element of A, then how do you write this? B does not belong to. Okay. Similarly, so if you take the set B, which is going to be the set of vowels in English alphabet, then how do you write it? A belongs to capital B, but you'll write B does not belong to capital B. This is very basic, right? So similarly, in the set of prime numbers, if P is taken to be the set of prime numbers, prime factors of 30, then what you can do? For 30, what are the factors? What are the prime factors? 3. So you can write them as 2, 3, 5. So all are prime numbers, right? Because 15 is not a prime number. They told prime factors. No, 15 is not a prime. Are you able to understand? So it is 2, 3, 5. So I hope this point is clear. 3 belongs to P, but 15 does not belong to P. So keeping this in mind, like what is the format that we need to follow as per the rules that are given to us? What are the two formats? One is called as the roster form, or we call it as tabular form. And the next one is called as the set builder form. So set builder form is you will write some condition, right? So in the roster form, how do you write it? All the elements of the set are represented within, right? This is called as a parenthesis, right? You put it within this flower bracket. Like, how are the elements separated? The elements are separated by a by a comma, right? And they're enclosed within these braces. For example, if you need to write the set of all even positive integers which are less than 7, what are the even positive integers which are less than 7? 2, 4, and 6. So if I give the name of that set as A, then how do I put them within this bracket? You will write it as the first element 2, 2, 4, 6, and just close the bracket, you're done. So it consists of how many elements? 3 elements, right? So some more examples of representing a set in a roster form are given as below. So a set of all natural numbers which divide 42. So what are the natural numbers which are going to divide 42? So here they didn't impose any condition. Let's think of the logic. So 42, what are the numbers you can think of? First, 1 is there, no, 1 is there, then 2, 3, 4 divides, sir. 5 doesn't divide, 6 doesn't divide, 7. So 6 does, 6 sevens, no. 6 does, 7 does, 8 does not do, 9, okay, 10. So like this, you can write it, no. So what you can do is after 10, what you can do is, see 3 into 1 is 3, 3 into 2 is 6, it's already there. 6 into 2, it will not divide, 12 will not divide, no. 7 into 2, 14 does. Then you have 21 that does. Then what else you have? 42 itself divides itself. So you put all these things, then you are going to get the set of natural numbers which divide 42. See, this kind of concept will help you in the chapter probability. In probability, what do we see? In probability, you have something called as sample space. You have heard of this? So what is sample space basically? It's a collection of all favorable outcomes, right? When you need all favorable outcomes, it is better if you put it in this format, right? It will give you a count of that, which will help us to calculate the probability faster. Okay. Okay, all the outcomes, please. Yeah, all possible outcomes. Yes. So I'm sorry. Yeah, it is all the possible outcomes. Collection of all the possible outcomes. Just give me a minute. Can you shift that side? Can you shift there? Shall we see the next example? See, all these things are very simple, man. The set of all vowels in English alphabet is given as AE, IOU. Similarly, the set of odd natural numbers is represented as 1, 3, 5, so on. Right? So, what do these dots tell us? These dots tell us that it's a never ending set. Right? Next. So, this is all about the roster form. Then, what about the set builder form? How do you write it in the set builder form? Sorry? So for set builder form, the first thing is, instead of writing multiple elements differently, you will give one variable to all the elements and you will define a condition of what that variable does. Am I right? See, for example, in set builder form, all the elements of a set possess a single common property. You will define the property of it, single common property, which is not possessed by any element outside the set. For example, if I need to write this AEIOU, right, in the set builder form, then what am I supposed to do? What is the property they follow? They form vowels, right? So you first give the name to a set is equal to, you will open a bracket like this, then you will assign a variable to all the elements, right? You will assign a variable x, for instance. Then you will put two dots like this. So how do you say? X such that x of which alphabet? English. Simple, no? Right. This is what we call it as set builder form. So when you extend and write this, it is going to give you the roster form. So they can always be interchanged among those. Right. So I hope this is clear. Just make a outline of this point. Ananya, I hope it is clear. Shall I proceed? So here they have mentioned what it means. The dot means such that, the colon means such that, and you know, can you see? Okay. See, if you take the set A, what is it you're able to understand? A is equal to set which contains the elements x such that x is a natural number, and that natural number is ranging between 3 to 10, where 3 and 10 are not included. Then how do you write this in the roster form? So it is going to be 4, 5, 6, 7, 8, 9. Right. Similarly, okay, if I take this one, so A is equal to x such that x is a natural number which divides 42. This is actually formed from the example that we discussed. So that's what they have mentioned. Similarly, y is a vowel of the English alphabet, and here z is an odd natural number. Okay, odd natural number 135. You had the dot dot dot. No, that example. Yeah. So that's called as an infinite set, basically, about which we'll see next. Now, tell me how to solve this problem. Okay. So write the solution set of the equation x square plus x minus 2 in roster form. So what is it going to be? So x square, is it minus 2? Plus 2x minus x minus 2 is equal to 0. So x into x plus 2 minus 1 into x plus 2 is going to give me a 0. So x is equal to 1 or minus 2. In terms of roots, these are the two values. So when you write it in the roster form, if suppose I call the solution set as S, it's my wish. Then I'll write that S as or minus 2 comma 1. It can be anything. Similarly, if you have multiple elements which are repeating, you write it only once. Okay. So I hope it's clear, no? This is an example problem of your textbook. So just make sure, though you know it, no, make sure you're writing it for your brain to be active. right? So 1 comma, you need not write the question, just write it as example 1 and the solution. Done. Next. This is going to be the solution. Next. Example 2 is write the set x such that x is a positive integer and x square is less than 40 in roster form. So let me name the set as A. Then A will be equal to, tell me, x is a positive integer and x square is less than 40. So what is the least value it can take? How because x square is less than 40, so x is less than 6 point something. Why 7? It is 6 point something. No? So what is the least integer you are going to write on the end? 6, right? So what should be the answer? 1, 2, 3, 4, 5, 6. See, this one, I'll explain how to handle it. So I'll explain it. Will you be able to understand? Can you try? I'll explain a method of how to handle inequality. It is not x square is equal to 40. It is x square less than 40. Right? See, when I write x square is less than 40, right? Can I write x square minus 40 is less than 0? Right? So it is of the form a square minus b square. So can I write this as x minus root 40 into x plus root 40 is less than 0? Can I write it like this? So you all know what is a number line that starts with 0. Then you have 1, 2, 3, minus 1, minus 2, minus 3, something like this, right? So the value of x, I will not say value, the values of x is to be chosen in such a way that when you substitute in this, the product of both should be a value less than 0. Are you able to understand what I'm trying to say? See, for example, if I substitute 1 here, so square root of 40 is 6 point something. So 1 minus 6 point something is going to be negative, and 1 plus 6 point something is going to be positive. Negative multiplied with positive is negative. Less than 0 means negative. So like this, what is the limit that x can take so that it does not become positive? Means I should substitute a value something like this. I need to substitute a value which is between minus root 40 to plus root 40. You substitute any value between these, where I put this kind of braces, right? So these braces are not to be confused with set. These are the ones which are used to represent the range. So this is called as open bracket. So I'm not sure if you have heard of some. You have heard of this? Yeah. Open bracket means the extreme values are not included. They are included. Okay. So having this in mind, I'm trying to say that this is the required set. About inequalities, you learn it in a chapter called as linear inequality. Till then, but that concept is important for functions. Okay. So I've just told you how these numbers are taken. When we deal in functions, right, I'll tell you how to deal this in more detail. But as of now, you're able to visualize what I'm trying to say, no? So you understood? You can make a note of this. You read it as x belongs to minus root 40 to 40. That's it. You should not take. See, actually, x can take, according to this, x can take those values. According to this, you should take only positive values. So it is basically intersection. You have learned intersection, right? Basically, intersection means I need to take the values from 1. Okay. So basically, when you see the word and, it is intersection. If you see the word or, it is union. Okay. Shall I proceed? So write the set A in set builder form. If you look at them, the numbers are 1, 4, 9, 16, 25, which are perfect squares. So how you write it? A is equal to assign a variable x such that x is a of whom? Of natural numbers. I cannot write integers because 0 is included. If at all you want to write it in terms of integers, right? You have to write x is a perfect square of integers except 0. Yeah. So you'll not write not equal to, you'll say x is a perfect square of all integers except 0. So even that it works, no? 1 square is also 1, minus 1 square is also 1. Right? So this is one way, or you write it like this: x such that x is equal to n square, where n belongs to the natural number set. This is another way. You can either write it in the statement format or in the mathematical representation. Both mean the same. Okay. Shall I proceed? Yeah. Small n is a variable element, capital N is the set names. Shall I proceed? So write the set half, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in the set builder. So A is equal to x such that n divided by n plus 1, where n belongs to natural number. So because that is the first number I'm able to see. So 1 divided by 2, 2 divided by 3, it goes on like this. This is a mathematical, we can't. So you have to write it as it is a fraction of a natural number divided by the natural number, the corresponding natural number plus 1. You have to write that big statement. It should be grammatically right. But one point to be noted is I should not write it as n belongs to capital N. And n should be less than 7 or less than or equal to 6. Right? Because it's a finite set. It's not an infinite set. Or directly what you can do is, instead of writing n belongs to n and this, you can also write it as n is less than or equal to 6, greater than or equal to 1. That also makes sense. No, you need to, because what if the question started like this? What if the first number itself was this? Then you need to mention the range of what natural numbers you're taking, no? But in this case also you need to mention it. You need to mention it. Because natural number, obviously, yes, it starts with 1. But here we need to be clear. Which set of natural numbers are you taking in the place of n? You start with 1, you end with 6. Right. So this one you're saying, go. Capital. Yeah. So match each of the set on the left described in the roster form with the same set on the right side described in the set builder form. So 1 is related to D, right? 0, what is it? So x is an integer and x plus 1 is equal to 1. So this is the one. So 1, 2, 3, 6, 9, 18. They look like multiples of 3 or they are divisors of 18. So the third gets mapped to A. 3 comma minus 3, x square minus 9. 0. See, x is such that x is an integer. So you have integer and x plus 1 is equal to 1. 1 and 1 get cancelled. X is equal to 0. So is 0 an integer? Yes. So 3 comma minus 3. So x is an integer and x square minus 9 is equal to 0. So basically what you get here, x minus 3 into x plus 3 is equal to 0. So x will be minus 3 or 0. Here. Capital, that's fine. But generally we represent it in smaller. But here they have taken it like that. No, each is treated as an object. They wrote it like. Don't look at them like a letter. Look at them like as an object. Look at them as an object. It's capital P or small p. Just it's a part of that word. That's it. Okay. See, why we generally, it's not like you cannot do it. The reason why they kept it like this is, see, for example, in the previous problem, this one is there, no. Can I not write it like this? Is it wrong? It is not. See, you can ask me a question. So if you give this paper to someone, what will they understand? Just create the differentiation, use small and uppercase. You're able to understand. It's still my wish. I will say, this is a variable. I am able to understand. This is a variable such that this variable is some number divided by n plus 1, where that number belongs to natural number set. But what did we do? For you, instead of writing 1, 2, 3, 4 for the natural number set, you have already given capital N for natural number set. Then why do you want to confuse someone with using the same variable? But according to what I wrote, this represents what? This represents this n. But others will get confused. That is the reason why they created the differentiation. It is not like you should not do it. Okay. So here, the same thing is done. You treat that as an object. Don't look at like an English letter. Treat it like an object, put it there. I hope I'm clear. I think we have the solution. We are done. So for exercise 1, let's try to answer this. Which of the following are sets? So the collection of all months of a year beginning with the letter J. What are they? Jan, June, June. Right. So it's a collection. Yes, it is right. 1 minute. The collection of 10 most talented writers of India. It is not because according to you, someone might be talented. According to me, they might not be talented. So it is not a well-defined collection. It can be a collection, but it is not well-defined. So what will be the reason you will write? It is not well-defined. Right. This one, a team of 11 best cricket. So wherever this word best comes, it's a debatable topic. Not. So it is not. So the collection of all boys in your class. Yes. So the collection of all natural numbers less than 100. Yes. So why we call them as a perfect set is because you and I write the same answer. But for these two, each one will write different answer. Right. So the collection of all natural numbers less than 100 years. The collection of novels written by writer Munshi Premchand. Yes, it is, because you have fixed the author. Yeah, best novels, then it will become, it is not a well-defined set. So the collection of all even integers. Yes. The collection of questions in this chapter. Yes. A collection of most dangerous animals of the world. Not a set. Right. So what about the second one? Let A is equal to 1, 2, 3, 4, 5, 6. It's the first 6 natural numbers, or I will say the first 6 positive integers. I can define it in any way I want. Right? Insert the appropriate symbol belongs to or doesn't belong to in the blank spaces. 5 belongs to 8. It's simple. Right? So write the following sets in the roster form. So A is equal to x such that x is an integer and it lies between -3 to 7, where -3 is included, 7 is not included. So for the first one, the answer is going to be A is equal to -3 is included, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Right, this is done. B, x is a natural number less than 6. So A will be equal to 1, 2, 3, 4, 5. Natural number less than 6. Right. C is such that x, so C is equal to x such that x is a 2-digit natural number such that the sum of the digits is 8. So what do you get? 2-digit natural number such that the sum of its digits is 8. So what is the first 2-digit number you can think of? 17. So after that, it's very simple. Increase this number 1 by, decrease this by 1. So 17, 26, 35, okay, 53, 62, 71. That's it, right? After that, you cannot have. So x is a prime number which is divisor of 60. So is that all? That's it, huh? So 60, what is that you're going to get? 2 times 30. So 2 times 15, 2 times, sorry, 3 times 5. After this, we are going to stop. So what will be the numbers? 2, 3, 5, correct. So D is equal to 2, 3, 5. That's it, no? Yeah. So what about set E? The set of all letters in the word trigonometry. So how do you write it? TRIGON. There is another O, you will not repeat it. So N, M, E, Y. First R is repeated, T is repeated. So for the sixth one, the set of all letters in the word better. B, E, T. I hope it is clear. It is B, E, T, R. Right. So Ananya, are you there?
Yes, sir.
Okay. So write the following sets in the set builder form. If I call the first one, if I take the set to be A, then the set is such that X, where X is equal to 3 times N, where N is less than or equal to 4 greater than or equal to 1. Just knock it. So n is greater than or equal to 1, less than or equal to 4. Right. So second one, b is equal to 2, 4, 8, 16, 12. X such that x is equal to 2 times n, where n is greater than or equal to 1, less than or equal to, are we getting everything? 2's, but no, it is not 2n. It is 2 power n. I'll write it from the beginning. So for the second one, let me take b is equal to x such that x is equal to 2 power n, where n is greater than or equal to 1, less than or equal to 5. Right. What about the third one? So c is equal to x such that x is equal to 5 power n, where n is less than or equal to 1, greater than or equal, sorry, n is greater than or equal to 1, less than or equal to 4. What about 2, 4, 6? So d is equal to 2n, where n belongs to natural number. Right. What about the fifth one? E is equal to x such that it is n square, where n belongs to capital N and n is less than or equal to 10. Right? Or the other way of writing this is n is greater than or equal to 1, less than or equal to 10. Both are right. If you write this, that is not needed. Am I clear? So fifth one. I'll write it here itself. List all the elements of the following sets. A, x such that x is an odd natural number. So 1, 3, 5, odd natural number. B is equal to x such that x is an integer, which is between minus half to 9/2, which are not included. Minus half is minus 0.5. So the first integer you will get is 0, 1, 2, 3, and 4, because this is 4.5. So you'll get a value less than 4. Sorry, less than 4.5. Third one, C is equal to x such that x is an integer and x square is less than or equal to 4. You will have minus 2, minus 1, 0, x square minus 4. Okay, see, this part alone I want to explain. When you have x square minus 4 less than or equal to 0, so it is like this: x minus 2 into x plus 2 is less than or equal to 0. So the least value will be minus 2 and the greatest value will be plus 2. So you will have x belongs to minus 2 to 2. This is the meaning. Okay, from minus 2 to 2, you need to pick only those integers. So minus 2, minus 1, 0, 1, and Root 40. This is easier. Okay, this is applicable when you have the value less than or equal to 0. For example, had the question been less than 4, then it would have been open bracket. So -2 and +2, you should have not written here. Am I clear with this? It's a very simple point, but to be noted. So here it is less than or equal to 0. That is why the extreme values are included. That is why I wrote -2 and 2. Had the question been x square is strictly less than 4, I should have not written -2 and 2. I should have written only the values instead. Make sense? Yeah. Okay. Square bracket, if you put it right, if you write it like this, -2 and +2 are included. If you put like this, -2 and +2 are not included, -1.99999999 is included, and +1.99999 till 2, like the last value till 2 is included, but 2 is not. So this one, X is a letter of the word loyal. L-O-Y-A. X is a month of the year not having 31 days. Feb, March has April, August doesn't have August not included, no. September, that's there, no. September, then October is eliminated. Then what you have? November you have 30, then December again 31. So these are the months. Right. So sixth one. X is a consonant in the English letter which precedes K. What do you mean by precedes? Before. So what are they? H, I is eliminated, J. That's it. So that is the answer here. Right? Yeah. Everything after. Okay. Just make a note of this. I'll be back. Yeah. So what about the sixth one? Match each of the set on the left in the roster form with the same set on the right described in the set builder form. 1, 2, 3, 6. X is a natural number and divisor of 6. So 1 is to C. 2, 3. X is a prime number and a divisor of 6. So here, why did we not take this into consideration? Because they use the word prime number. 1 is not a prime number. At the same time, 6 is also not a prime number, right? So MATHEICS. They're obviously from the letter. So they are the letters of the word mathematics. 13579. Simple. Right? So this is with respect to the first exercise. Now we are going to learn about the different types of sets. So first part, what we saw was, like how you write the elements in different forms. What are the two forms? One is the roster form and the second is the set builder. Now the next point that we are supposed to learn is, what are the different types of sets? So when you talk about the different types, whenever you talk about the word types, right, whenever you're doing the characteristic changes, you need a differentiating factor among them. So what is going to differentiate the sets into their types is what the question is. So the first one, if you see, you're saying something called as an empty set. The name itself is suggesting. What is an empty set? So if you don't have elements at all, you call it as an empty set. So what is the differentiating factor here? Depending on the number of elements. If the number of elements in a set is 0, you call it as an empty set, right? See, for example, the number of elements in set means that 0 is also an element. If you count it, it is taken as one object, right? So consider the set. Suppose they have given an example. A is equal to X such that X is a student of class 11 presently studying in a school. So we can go to the school and count the number of students presently studying in the class 11 in that school. Thus, what will happen to the set A? Let's say that school has 11, obviously. So if you have count the number of students, there will be finite number of students, right? So now we can write another set B as follows. How do you write it? B is equal to X such that X is a student presently studying in both classes 10 and 11. Is it possible? Nobody can study both the grades at the same instant, right? So for this, what would be the value? This is the set builder form, right? Now, how are you going to write the same thing in the roster form? B will be equal to, just put the bracket, there is no element for me to write. So this is going to be an empty set. Tell me. Simultaneously, they cannot study. So in the same academic year, one cannot be in 10th grade and the 11th grade with the same institute. That is the reason why this kind of a condition is not possible. So if you ask me to write it in a roster form, I cannot write because I don't have elements in my. So it's an empty set. Right. So what is the definition? So now I understood from example that it is an empty set, but how do I define it properly? So a set which does not contain any element is called as the empty set, or it is also called as the null set, or it is also called as the void set. So generally, how do you represent a null set is, you put a circle like this and a line, which is called as phi, P-H-I, okay? So a null set is represented by the symbol phi, or you just put the braces and write nothing within it, right? So we'll see some examples. Let A is equal to X such that X is a number between 1 and 2, but you are putting a condition that X is a natural number. Had they said X is a real number, then you could have written 1.11, 1.111, 1.1111, like that you can write infinite number of values. But here, what is the condition imposed? Natural number. So obviously it is not possible, right? Next, B is equal to X such that X square minus 2 is equal to 0. and x is a rational number. Why? So you'll get x is equal to plus or minus square root of 2 is what you're going to. Square root of 2 is going to be an irrational number, right? So because of the irrational number, B is again going to be an empty set. Now C is equal to x such that x is an even prime number greater than 2. X is an even prime number greater than 2. What is the even prime number which is greater than 2? Nothing, because everything is a multiple of 2. So this is also an empty set. B is equal to x such that x square is equal to 4, where x is odd. X is equal to plus or minus 2. But plus and minus 2 both are even, right? So because of this odd, again it is going to be an empty set. Am I clear with this? Right. So if you have no elements, so I told you again, right? When you categorize the types of set based, so categorization is done based on the number of elements. If there are no elements, you call it as a null set. If there are finite number of elements, means if you are able to count those elements, then you call that as a finite set. If you are not able to count those elements, you call it as an infinite set. For example, if I take A is equal to 1, 2, 3, 4, 5 and B is equal to A, B, C, D, E, G. So here I have 5 elements. So it is basically written like the small n is used for number. Within the bracket, you put the name of the set. You read it as number of elements in set A is 5. Here the number of elements in set B is going to be 1, 2, 3, 4, 5. Again a 5. So you're able to count them. So these two are obviously finite sets, right? So if I take C, C is equal to men living presently in different parts of the world. You cannot define it properly because we don't know how many are there, right? So we observe that A contains 5 elements and B contains 6. 1, 2, 3, 4, 5. Oh, sorry. B contains 6 elements. So how many elements does C contain? Obviously, it is not predictable, right? So by number of elements of a set S, we mean the number of distinct elements of the set. We denote it by n of S. That's what I wrote. Small n is used for number. You read it as number of elements of set S, right? If n of S is a natural number and S is a non-empty finite set, then consider the set of natural numbers. Sorry, if n of S is a natural number, then S is a non-empty set. Consider the set of natural numbers. Leave this. Okay. See here, try to understand this. You have the number of elements in a set. If the number of elements in a set comes out to be a natural number, then it is a finite set. Right? It is non-empty, at the same time, finite set. But if you consider the set of natural numbers itself, then what will it be? It is infinite. It starts with 1, 2, it goes on till infinity, right? So, yeah, number of elements in A is 5, number of elements in set B is 6, and the number of elements in set C is going to be some finite number. I'm sorry, actually, we made a mistake. What about set C? Actually, set C is a finite set. Okay, set C is finite because of what reason? Because it will be some natural number which we don't know at this point of time, but it will definitely be some finite number. It's not infinite. It's not like men are continuously born or like every second they are not born, that it is increasing at an infinite. It's not like that. It's not like that. But it is definitely going to be some amount of value, right? It is going to be some value will be there, which is finite. Right? So actually it is a finite set. It can. You can define if you put a condition like Give me a set of the best men in the world. That is not. Men means it is well defined. Okay. So it was my mistake. Sorry. The number of elements in set C is some finite number. Hence, it's a finite set. Then what is going to be an infinite set? A set which is empty or consists of a definite number of elements is called as a finite set. Otherwise, the set is said to be infinite. Right. So consider some examples. Let W be the set of days of the week. Then W is finite. Let S be the set of solutions of the equation x square. It is actually x square minus 16. It is finite. You have two solutions. Let G be the set of points on a line. Then G is the number of points on a line is infinite. So it is an infinite set. So here it is finite. Here it is finite. So when we represent a set in the roster form, we write all the elements in the set within these braces, right? So if at all you're not able to write all the elements within the braces, then what you do is you take the help of dots, right? You take the help of dots like this. So the dots represent the set is going to be infinite. If not, they are going to be finite. You will write the last element. If you put the dots and you don't write the last element, it is going to be infinite. Okay, I hope this is simple. No? They're all very basic things. Right. Having said this, let's see how the problems are. State which of the following sets are finite or infinite. First one, x is such that x belongs to natural number x minus 1 into x minus 2 is equal to 0. X is equal to 1 or 2. So it is finite. X is equal to such x is such that x belongs to natural number and x square is equal to 4. It is finite. X is equal to plus or minus 2. So x is such that x belongs to natural number 2x minus 1 is equal to 0. X is equal to half. X is equal to half. So it is a null set. But null set is a finite. Right. X is such that x belongs to natural number and x is prime. X is such that x belongs to natural number and x is odd. So it is an infinite. Right? So finite, 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 infinite, infinite. Make sense? So I hope you don't need to copy all these things, right? Yeah, it's simple. So the next is about equal sets. So when do you say something is equal? When you have the same number of elements in both the sets and exactly the same elements in both the sets, you call them to be equal sets, right? So if two sets are given to you, A and B, if every element of set A is also an element of B, and if every element of B is also an element of A, then the two sets are said to be obviously equal. The other point that I told is the number of elements should obviously be the same, right? So for this, what is going to be the definition? Two sets A and B are said to be equal if they exactly have the same elements. And how do you write them? You write them as A is equal to B, right? This is how you represent it. See, for example, let's say there is a problem. X comma 1 is equal to 2 comma 1. Makes sense? Can it be? Is there a possibility? Number of elements here and the number of elements here are same. X comma 1 is equal to 2 comma 1. Find X. I can give you a question like this, right? I gave a question. So I first check the number of elements. So since the second element is 1, obviously the first element is supposed to be 2. So I told that they are equal sets, right? So let's consider the following examples. If you take A is equal to 1, 2, 3, 4, B is equal to 3, 1, 4, 2. Are they both equal? Yes, they are. They have the same number of elements and exactly the same elements. Let A be the set of prime numbers less than 6 and P be the set of prime factors of 30. So set of prime numbers less than 6, what are they? Prime numbers less than 6. 2, 3, 5. What about P? This is A. What about P? Set of prime factors of 30. 2, 3, 5 enough. So are they both equal? Yes, they are. Right. Example number 7. Find the pairs of equal sets, if any, give reasons. A is equal to 0, B is equal to X such that X is greater than 15 and X is less than 5. Okay, let me write all the sets. So A is equal to 0, B is equal to X such that X is greater than 15 and X is less than 5. So what will be the elements? Dot, 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 dot. What will be the number less than 5? But they didn't say anything about natural number or something, no? See, this is the number line. This is 5. This is 15. Oh, X is a number less than, oh, they gave and, no? It's not possible, sorry. So it's going to be a null set. So C is X such that X minus 5 is 0. What about D? No. Minus 5 comma plus 5. E is such that X is an integer, sorry, X is an integral positive root of the equation X square minus 2X minus 15. So X square minus 2X minus 15 is X minus 3, X minus 5 into X plus 3. So X is equal to 5 or minus 3. So X is an integral positive root of the equation. So it is only 5. Minus 3 is eliminated. So which two sets are equal? C and E are equal. So set C is equal to set E. I hope it is clear. Right? No. For your understanding, you at the bottom, you need to write set C is equal to set E, or you just put capital C is equal to capital E, it is understood. Like this, you. So example 8. Which of the following pairs of sets are equal? Justify your answer. X is the set of letters in alloy and B is the set of letters in loyal. So X is what? A, L, O, Y. B is L, O, Y, A. They are equal, same number of elements and exactly the same elements. So 1, 2. A is such that, A is equal to N such that N belongs to Z and N square is less than or equal to. So answer. Is that all? See, listen. N square minus 4 is less than or equal to 0 implies N belongs to minus 2 to plus 2. Yeah, minus 2 to plus 2. So you need to take only integers. A will be minus 2, minus 1, 0, 1, 2. B X such that X belongs to R and X square minus 3X. So X is equal to 2 or 1. So X belongs to real number. And this thing. So there are only two options. 2, comma. They are not equal. So A is not equal. Right? So exercise 1.2. So first question. What is the time? This will do 3 to 4 problems and then we'll wind up. So which of the following are examples of null set? Set of odd natural numbers divisible by 2. Set of odd natural numbers divisible by 2, it is obviously not possible. Set of even prime numbers. So it is not a null set. So x such that x is a natural number and x is less than 5 and greater than 7. Y is such that y is a point common to two parallel lines. So you have two parallel lines, you cannot have any common point on them. So this is also a null set, right? So which of the following sets are finite or infinite? The sets of month of a year. This is finite. 1, 2, 3, so on. It is infinite. 1, 2, 3, so on till this thing is finite. The set of positive integers greater than 100. The set of prime numbers less than 99. It is finite. Right? So third one. State whether each of the following set is finite or infinite. The set of lines which are parallel to x-axis. The set of letters in English alphabet, they are finite. The set of numbers which are multiple of 5, they are infinite. The set of animals living on earth. The set of circles passing through origin, infinite. So I can define infinite number of circles, right? So fourth one. The following state whether A is equal to B or not. A is equal to ABCD and B is equal to DCBA. So equal. A is equal to 4, 8, 12, 16, 8, 4, 16, 18. They are not equal. Though the number of elements are same, what is the differentiating one? Here you have 18 and here you don't have 18. And similarly, you don't have 12. So 18 and 12 is creating the differentiating factor. So they are not equal. A is equal to 2, 4, 6, 8, 10. B is equal to x such that x is a positive even number and less than or equal to 10. So 2, 4, 6, 8, 10 equal. So A is equal to x such that x is a multiple of 10. Because 15, 25, these are all not multiples. So, yes, they are not equal. Okay. So we'll do one last problem. Fifth one. Are the following pairs of sets equal? A is equal to 2, 3. B is equal to x such that x is a solution of x square plus 5x plus 6. So here you will have x is equal to minus 2, minus 3. They are not equal. Right? A is equal to x such that x is a letter in the word follow and y is a letter in the word wolf. So what are the letters? F, O, L, W. So W, O, L, F. So they both are equal. Right? So the remaining problems I'm expecting you to solve it. Right? You have the solutions in the book also. You can have a look at it and then solve it. Tomorrow we'll start with the next exercise. So this chapter, since it is simple, right? I'll go with two exercises in a class. Right? So I think you have 6 exercises. Right? So by next week we'll complete it. And I want to mainly focus on the concepts of relations and functions. No, next chapter. No, I'm saying I'll teach all those things. These things we'll do it. You will understand also. I'm talking about I'll be concentrating more on the chapter relations and functions. That is very, very important. Okay. Ananya, there? Ananya, are you there?
Yes, sir.
Yeah. I hope it is clear, right?
Yeah, it is clear.
Okay. So the remaining problems, I want you to solve it. The next set of problems we'll see in the next class.
Okay.
Yeah.
Thank you.
Yeah.